Hello everyone! In this video I want to show you how to connect an external LED, a light like this one, to a microbit circuit board like this one. Either version works, version 1 or version 2, whatever you have. And the only thing you will need for this project is 2 crocodile clip cables. So if you're interested to see how to do this project, just watch the video. So now that you're seeing the close-up, let me show you what you need for the project. As I mentioned, you will need a microbit circuit board. You will need a LED, so whatever color you feel like, it's fine. You just pick one. You will also need a USB cable that is compatible with the microbit, so you connect one end here and the other end to the computer and program the microbit to actually make the connection with the LED and make it light up. Of course, the most crucial part of the project is 2 crocodile clip cables. This is what a crocodile clip cable looks like, so both ends look like this, like actual crocodile mouth, and you use this in order to connect to one of the pins, like this one, for example. So you need 2 cables, and something optional, but it would be nice to have, is a battery cage that you can connect to the microbit, so it has an external power source, so that you can get the microbit and walk around the room, show your project to other people or students or whatever. But it's sorry, it's optional because you can still use the laptop as an electricity source, so the program will be running perfectly just using the USB cable if you don't feel like going around the room. So the battery cage is optional. The first step is to connect the USB cable to the microbit and then to your device of choice, and voila, it's connected. This is the blog post I have written about this project, how to connect the external LEDs with the microbit. I will leave a link to this blog post down in the description of this video if you feel like reading it or like using it for reference. But yeah, it includes a link. You don't need the blog post to get to the link. It's the MakeCode coding environment. When you go there, like, the website is literally called just makecode.microbit.org, and this is where you program your microbit. You click on new project, you name your project like external LEDs, create, and here's the empty project that we are going to be using. So we don't need the forever block for now. We start off simple. Then we are going to be using the advanced menu right here, and then click on pins. Pins are, whoops, let me unplug that. These here are called pins. So this is pin 0, pin 1, pin 2, pin 3V, and pin ground. GND stands for ground. These are the pins of the microbit, and you can control these pins using this menu and the blocks right here. This one, digital write pin. So what this block does is you choose a pin, like if the microbit has other external pins connected to it, you can use the other ones. But as you saw in the standard microbit with no extensions, we only have pins 0, 1, and 2. So we will be using pin 0. And in computer science and programming, maybe you know, if you don't, I'll tell you anyway. 0 means nothing, it means no, it means false, it means no electricity. So if we leave it like this, it's not going to give any kind of electricity to the LED because it's set to 0. But if we set it to 1, this means yes, it means true, it means there is electricity. And as you can see right here on the simulation of how the project looks like when when this code is run. This is the microbit circuit board. This is pin 0, and as you can see, pin 0 is right now highlighted in orange and it says 1 here. So it means that the circuit board is sending electricity right to pin 0. And what does an LED need to light up? It needs electricity. Let's see how the project looks like on the actual microbit. There's two ways you can do this. First one is manually downloading the program, or you can do something more convenient, like pair your microbit with the computer. Okay, now that we downloaded the project to the microbit, let's test it out. This is a microbit, it's still connected to the laptop. You can use this as a source of electricity, or you can use the external batteries. Then we take the LED. Mine's a bit wonky, I'm sorry about that, but I used this LED in another project with my students just yesterday. So as you can see, the LED has one leg shorter than the other. The long one, you should remember, is the plus sign, and the shorter leg, this one, is the minus sign of the LED. So I will grab the red cable, it will mean electricity, and I'll connect it like this to the long pin of the LED, like this. So it's very important that these two legs don't touch each other, and that the metal part of the, oh, is this focused? I'm sorry. The metal part of the LED, of the crocodile clip cables, does not touch both legs, so it only touches one, the one that it's supposed to be touching, and then its other end is connected to pin 0, like this. So this is how it looks like so far. Then I'll grab the other one and I will connect the minus leg, this one. Okay, careful that it doesn't touch the other one. And I will connect it to the GND pin of the microbit. GND means ground, so that, oops, spoiler alert, it's working. This is the minus of the microbit, so that we have a closed circuit here. I connect it to the GND pin, and as you can see, the project is working properly. Let's see how we can complicate this project a little bit with code. Let's say we want to make this LED blink. So disconnect these, or actually you don't need to disconnect anything, just connect the USB. It's a good decision to unplug the batteries when you're using the USB, because both are giving the circuit board electricity. So like this, I just connected it to the laptop. Let's see the coding part. Yay, I love coding so much. Okay, this is the program that we have currently running, and it's currently always on. This is what one means. But let's say we want to make a pause of like half a second. So go to the basic menu, grab the pause block, and it works in milliseconds. So 1000 milliseconds means 1 second, and if we want half a second, we're going to pick 500 ms or milliseconds. And afterwards, let's duplicate this block. Afterwards, we want to turn the LED off. So do you remember what this number meant? It meant on. And what means off? 0. And if we want this to be like a little loop, we have to add another pause block like this one. So now it's on, pause, off, pause. If we want this to keep blinking forever, we have to put it inside of a loop. So we go to the loops menu, and we can loop it like a couple of times if we want with the repeat block, or we can make it loop indefinitely with the while do block, and we just have to set the condition to true. It means that as long as this block is true, it will keep looping whatever is inside like our program. And because we did not specify any condition, it's always going to stay true and it's always going to continue looping. And as you can see here in the simulation, it's going to loop the on-off block indefinitely forever. I just click download and this is all it takes. Inconvenient. Whoops. So let's see what happened. Wow, it's working already. As you can see, the loop is working its magic and now my LED is blinking away. Whether you're teaching STEM, introducing circuits and electricity like me, or just starting out with the microbit, this is one of the easiest and most satisfying first hardware projects you can do with your students, in my opinion. It's a great entry point into coding and physical computing, and also perfect for beginner engineering lessons, so it's a very versatile project to have in your teacher toolbox. And it's exactly why I was so happy to share it with everyone. If you want to do this project with your whole class, but in a more creative way, then I have created the perfect resource for this, where the students have to make these little light up cards. They are so much fun. My students always love it, and I do this project almost every year since 2018, when I first created the idea, when I first came up with the idea about this project. And I will leave a link to this resource down in the description section of this video. This is a note clip that I found of the resource that I'm talking to you about, that I made especially for this project. This is how I do it in my own classroom, and it's always so much fun, and the students are always eager to use their creativity and to add some coding and physical computing to the whole mix. And really, you should try this project with your own students. And if you decide to do this project with your whole class, maybe with your summer camp students or anyone that you want to do it with, please let me know in the comment section of this video, because I'll be so happy to see my project going live around the world and people actually having fun with my little idea. You can also write an email to me or like message me somewhere like Instagram or Facebook. I'll be leaving all the links down in the description box of this video. I hope this project was as fun for you as it was for me creating it and like explaining and telling you about it. And I really hope that you have a lovely day and happy teaching. Bye!